This Zoom session is being brought to you by the fractal inverse bullseye horizon. All right. For today, we move on to section 4.2. Now we're seriously getting into actual triangle measuring. This is the law of sines, which will enable us to solve various kinds of triangle solution problems. Angle, side, angle, side, side, and side, side, angle. All right, fine. We start off with a triangle where the sides A and B and C, well, don't do that right here. Opposite side A is angle alpha, opposite B is angle beta. Here's angle gamma, and there's a height H, a perpendicular. We drop a perpendicular for this altitude of H. H over B is opposite and it over hypotenuse for alpha. So H over B is sine of alpha. H over A likewise is sine of beta, opposite over hypotenuse for beta. So therefore H equals B sine alpha and H equals A sine beta. So these are equal. B sine alpha equals A sine beta. After divide by sine beta and sine alpha, we get B over sine beta equals A over sine alpha. A side over the sine of the opposite angle is the same for this pair and for this pair, and it will be also true for this pair, C over sine gamma. If we have a true trigonometric identity, then it remains true when we swap labels, alpha to beta to gamma to alpha, A to B to C to A. It's because the letters A, B, C, alpha, beta, and gamma are our ideas. They're not the triangle's ideas. So side over sine of opposite angle is the same for all three pairs. A over sine alpha equals B over sine beta equals C over sine gamma, and this is called the law of sines. The idea being that if we have given the three angles alpha, beta, and gamma, and one side, let's say C, then we can solve for A and B. Transpose sine alpha and get A equals C sine alpha over sine gamma. Transpose sine beta and get B equals C sine beta over sine gamma. So given three angles and a side, we get the other two sides. Now, if we have two angles, alpha and beta, then the three angles add up to 180. So gamma, the third angle, is 180 minus alpha minus beta. Similarly, beta is 180 minus gamma minus alpha, and alpha is 180 minus beta minus gamma. So given two angles, we get all three angles. So given two angles and a side, we get all three angles and therefore the other two sides. Given angle, side, angle, we get all three angles and all the three sides. Angle, angle, side is when you're given an angle, and a third side opposite one of the two angles. Angle, side angles, you have an angle, a side, and an angle, the side between the two angles. So, for example, here's a triangle, and here's an angle 45 degrees, alpha. Opposite B is angle beta, 25 degrees. Between them is side C, 12.0 units. What is angle gamma? What is side alpha? What is side beta? And now, so we have two angles, so we get the third by subtracting them from 180. So gamma is 180 minus 45 minus 25. After a little bit of calculation, that's 110 degrees for gamma. So now we have a side C and its opposite angle gamma equal to 110 degrees. And by this formula, we'll get that A equals C sine alpha over sine gamma. That's 12.0 sine of 45 degrees over sine of, oh my dear, how did I manage? Oh dear, I don't know how this happened. Although it comes to this, no, it doesn't. This is a mistake. This should be 110 degrees. This should be 110 degrees. These are erroneous. Oh my God, I get honked. I'm going to have to change that, which is this. Page 2, is it 422? Change 422 sine of 110 degrees. My apologies. Well, okay, these are off. In fact, let's figure it. This should be 12.0 sine of 45 degrees. Let's make sure I'm in the right mode. Divided by sine 110 degrees. It's more like, okay, this is more like 7.97. This needs to be changed. Oh dear, and I bet the whole rest of them will be as well. We'll see. Okay, here we have an angle side problem. an angle here, 47 degrees, that'll be alpha. Here an angle beta of 23 degrees. And this side A, opposite alpha, is 51.2. So what's gamma, what's B, and what's C? Gamma, well, it's 180 degrees minus 47 degrees minus 23 degrees, which is again 110 degrees. And so this will be A over sine gamma over sine alpha. B will be, let's see, A sine beta over sine alpha. 51.2 sine 23 degrees over sine 47 degrees. Since I suddenly distrust everything I wrote here, I'll work it out. Sine 47, 27.354. Okay, fine, roughly, to 4 decimals. And similarly, C will be, okay, it's A over sine alpha, 51.2 over sine 47 here, times sine of gamma, which is 110 degrees. That comes out to 65.782. Here we have, well, okay, they originally, in the book, they have, this is the top of a mountain, and here we crane our necks up 25 degrees. That's called an angle of elevation. When we back off 1,000 feet, and then we have to crane our necks by only 15 degrees. The question is, what is this distance PQ? Okay, now, PRQ is 15 degrees. RPQ, this angle in here, is 180 minus 25 degrees, which comes out to 155 degrees. Then this angle here, PQR, will be 180 minus 15 minus 155. That comes out to 10 degrees. So PQ over sine 15 degrees, side over sine of opposite angle, PQ over sine 15 degrees, equals 1,000 feet over sine of this angle, which we determined as 10 degrees. So PQ is, if you transpose, 1,000 feet times sine of 15 degrees over sine of 10 degrees. That's about 1,490.5 feet. Now, these next problems are rather more difficult. These, so we did angle, side, angle, and angle, angle, side. They're fine. Now, here is a little bit more difficult one called the side, side, angle problem. It could be written angle, side, side, but I won't for obvious reasons. It's also called the I also call it the pendulum. The idea is this: we have an angle, we have a side, we have another side. And so, okay, what's this angle at the top? What's this angle over there? What's this side C? Given alpha, B, and A. Find beta, gamma, and C. Now, we have started with the usual law of sines relation, B over sine beta equals A over sine alpha. If you solve for sine beta rather than for B, we first have to flip both of these upside down, sine beta over B equals sine alpha over A, transpose the B, and get sine beta equals B sine alpha over A. Now, the thing about this is that B sine alpha over A could be less than 1, or could, like here, or could equal 1 like here, or could be greater than 1. Now, the trouble is, if this is greater than 1, then there is no angle beta which equals that bigger than 1 number. So if B sine alpha over A is bigger than 1, then there are no solutions. This is why I call this a pendulum. I'm imagining this as a pendulum at the end of a cantilever. And if we raise up the cantilever too high, then the pendulum swings free and never touches ground, so there's no triangle. If B sine alpha over A equals 1, then this swinging pendulum touches ground just barely, grazes the ground at 1 point. This will be one solution, a right angle triangle. And if B sine alpha over A is less than 1, then we lower this cantilever a little more, and then this pendulum hits the ground at 2 points. There's 2 solutions. Here's where beta is arc sine B sine alpha over A, or for this solution, beta is the obtuse angle 180 degrees minus arc sine B sine alpha over A. Therefore, this is called the ambiguous case. There could be 2 solutions, no solution, 1 solution, or 2 solutions. Now here we're going to, now I'm going to solve this by the law of sines. But in the notes in the extra credit sets, there's an alternate solution by what's called the law of cosines, or by approach that yields the law of cosines. So, for example, suppose that B is 5, C is 3, and beta is 100 degrees. What's A, what's beta, what's gamma? All right. So we're given B and beta. So there's an angle on the opposite side. We have side C. We need the opposite angle gamma. Here's the relation. B over sine beta equals C over sine gamma. If you flip these upside down and transpose a C, you get that sine of gamma equals C sine beta over B. So you plug that in, that's 3 sine 100 degrees, or 5, which is 0.59088. That's less than 1. There's two solutions. Sine gamma equals 0.59088. Now solve an arc sine problem. Imagine the unit circle. Go up a distance 0.59088. This angle has the correct sign. So does this angle. And this angle and this angle are complements. Supplements, 180 minus each other. This angle here is arc sine 0.59088, which is about 36.22 degrees, or the gamma is 180 minus this arc sine, which 180 minus this, which comes out to 143.78 degrees. So there's two solutions. Well, or maybe there's two solutions. So I'm going to draw two tables here just to make sure to accommodate both. We're given that beta is 100 degrees here and here. B is 5 here and here. C is 3 here and here. And gamma is 36.22 from here, or 143.78 from here. Now, next step is to find alpha, which would be 180 minus beta minus gamma. So 180 minus 100 minus 36.22 gives you 43.68. This one, something goes wrong in a very interesting way. 180 minus beta minus gamma is 180 minus 100 minus 143.78, which gives you a negative angle, negative 63.75. The reason why is that C, this side here, was shorter than equal to 3, is shorter than B, this side here, which equals 5. So when the pendulum swings, one of the two solutions ends up here, fine, but this other one winds up back behind point B, and so that's not a valid solution. So this is one we can throw out. So, however, sides of angles of 100 degrees, 36.22 degrees, 43.78 degrees. We're given B is 5 and C is 3. So to find A, we use the law of sines again. And because we were originally given B and beta as opposing side and angle, we'll use that. So A will be B sine alpha over sine beta. Do 5 sine of this, 43.78, or sine of beta, which is 100, comes out to 3.513. So this triangle has this one solution to this triangle. Let's try this. A equals 2, C equals 1, gamma is 100 degrees. What's alpha, what's gamma, what's beta? All right, so we're given C and gamma. We're given A, so we need to find alpha. C over sine gamma equals A over sine alpha. You flip both of these over, move A over to the other side. Get the A equals A sine gamma over C. That'll be 2 sine 100 over 1, which is about 1.9696. Bigger than 1, and therefore, like this, there's no solution. So let's solve this one. Okay, I think that covers these. Oh, yes. Let me move on to the modules. In the modules, we go through the same thing. If you look here, you'll see that we have, where did I put it? Pendulum. This, and this, and this. These 6 pages. This page also describes the pendulum. Given an angle and 2 sides, what's an angle, a side, and a side? What's these other 2 angles? What's this third side? And as I mentioned here, 0, 1, or 2 solutions. Here, the 2 solution case can reduce to a 1 solution case. So it's called the ambiguous case. And I go through a very different formula. I'll leave you to read it here in the textbook. This is C in terms of alpha, beta, and alpha, A, and beta. This becomes a solution, the two solutions given plus or minus. And that's the pendulum law. And you find the other angles by means, which we'll be seeing next time, something called our law of arc cosines. From this, we derive something called the law of cosines, and from that we'll derive the law of arc cosines. We'll be discussing that next time. And so here's 3 cases of the pendulum law. Here's the law of cosines. Here's the law of arc cosines. And I use this to solve here. There's a case where there's no solutions. Here's a case where there's one solution. Here's a case where there's 2 solutions, this or this. And I give as extra credit 8 problems were asked, given a side angle problem, solve the triangle. Some of these have no solutions. Some of these have 1 solution. Some of these have 2 solutions. Okay, I think that's sufficient unto the day. So, well, okay, we have covered 4.2, or at least briefly covered. Like I said, I'm going to have to modify this problem set. I am so embarrassed. How did that happen? Okay, we'll get back to it later. And all right, so questions, comments, requests.
Yeah, I just got a quick question. I'm kind of embarrassed to ask this myself, but when we're doing the trig homework, when should we or do we have to switch to rads in our calculator?
Well, that depends. I mean, if for most of them, we're graphing y equals sine x. Usually it's in radians. But here, like this section, where we're doing actually solving triangles, they'll usually be giving you the angles in terms of degrees. So use that. Just use whatever is most appropriate under the circumstances.
Awesome. Thanks.
No problem. More? Okay. Well then, motion to adjourn. Is it seconded?
Seconded.
It is seconded. Okay, I shall be seeing you tomorrow. I have to fix this.
Thank you.
Yep. Have a good evening.
Thank you, Professor.
Yes. Thank you. Bye. Bye.
Oh. Oh, I see what happened. You're here twice.
Have a good day, Professor. Sorry I came in late today.
Things happen. I'll see you tomorrow. Oh, annoying. All right, we got it.